to start. You guys ready for in your studio? Okay, let's go then. I'm Norbert Bell. Some of you might know me. I am nominally from process engineering, but I work for projects. And today I work for the IT department a little bit. I coerce them to sit there because I want to see the monitor while I'm talking. I don't want to keep looking back and forth like this without the monitor. So the class, as far as I know, is composed 1/3 process engineers, 1/3 engineers from other disciplines, or designers from other disciplines, and 1/3 from various other departments of the company. And I don't know what it is today, but we're going to be talking about all the departments. And whenever I say piping, pipers should raise their hands. Anybody here from piping? Oh, good. You don't have to do that anymore. Thank you. Okay, so that's the class breakdown. We are going to be talking today about something that's different from what you've been talking about until now. Until now, you've been talking about mostly technology, refining this and hydrotreating that and what have you, with one exception when you were talking about using Pro 2, that was actually talking about our work. All the other sessions were about the technology. And being informative, I hope now everybody understands what's going on in a refinery. What we are supposed to do, as in any meeting, is to have a safety moment first. So has anybody had any near collisions this morning, for example? And you're going to tell others how you're going to avoid it next time? You did?
I didn't, but I witnessed one last week.
Oh, no. Okay.
We have some temporary desks set up that have been there for probably over a year. Mm-hmm. And instead of desks, they're tables, and they don't have the circle where all the cords go through. They're just draped over the edge. And people walk in front of those tables all the time. And last week, someone got their feet wrapped up in it, and had a pretty nasty fall, actually.
Oh, boy. So what's the morale of that story for us tonight, this afternoon?
Well, basically, we've got cords everywhere, so we should probably...
Yeah. So beware of these cords when you start walking around during the break or after class when you're rushing home. Make sure that you don't trip over chairs, tables, your neighbors, or these cords. Anything else? Thank you very much, Amy. Anything else? So that's very appropriate. So anything? Well, for example, what would you do if there were a fire right outside of this door? Or better yet, if you smelled smoke. If you smelled smoke, not knowing if there is a fire. And no detectors would go off.
That's still best.
You would investigate?
Yeah, to see if there was a fire.
Okay, so how would you do that?
Get up and walk outside, look around.
Yeah. That's my man. You would feel the door first, right? You would feel the walls also, not tables, but the walls, and figure out, okay, maybe there is something going on there, so I'm going to go the other way. And if the other way was also hot, you would choose the third door. We have four doors here, 5. This one looks like an entry into some cabinet. Okay. So, anything else that you want to talk about safety-wise? Okay. We are going to have a quiz at the end of tonight. So Can you guys, you can film it, right? But I wonder if you can see this well. Last time we did this, we turned off some lights, and miraculously, nobody fell asleep, because that always happens during the PowerPoint presentations. I'm going to try that.
You need a security guy? I can get him.
Yeah, there are a couple of switches that need to be turned off because they can't see this very well. We have tested it last time.
How about we switch it? Yeah.
No, you need to turn these on.
That might work right there.
That is the key. Okay. Can you all see on your notes?
Yep.
Okay. So we got that. So as I said, today we are going to be talking about our work processes. How do we do our work in order to accomplish what the company has set out to do or what the clients engaged us for? We are a consulting company. We provide services to others. Everything is okay? Okay. So, and most of our work is about bringing chemical products to the consumer. For example, gasoline, that everybody is familiar with, or some other chemicals, for example, sulfur, or sulfuric acid, and other products that are useful to the consumer. So at one time, I was studying all these breakdowns of how do we bring products to the consumer, and the most reasonable breakdown that we have sort of settled on was the 6 squares, and I've been really giving a hard time to process engineers. We have another course going on right now, and I keep telling them there are 6 squares. Each square represents a certain step in developing the chemical product and bringing it to the consumers. Now, for you, I have put it into some a little bit more understandable form, because I keep asking the process engineers anytime we come to these sessions, I point at somebody and say, what's in the 3rd square? And they have to say, it's the system design. Okay, so tonight we're going to be talking about bringing, and I need to turn it on, bringing the chemical products to the consumer. So this breakdown, as I said, can vary, but we're going to be using this breakdown. The first step in bringing the product to the consumer is actually design the product. And the product design is primarily done by other people, by other companies, except if you are in the sulfur group, they might be doing something in the way of designing the product. For example, the government tells us that we have to have carb gasoline, which is a special kind of gasoline where most of the sulfur gets removed, so our sulfur group might get involved in that, but normally they don't, or any other department we don't. Now, the second step would be process design. Once we have the product design, the properties tested, and we know it's going to sell, or we were told to do it a certain way, therefore we have to oblige the government, for example, in that case of carb gasoline. We do process design, and the process design is figuring out what process steps are required to accomplish the objective. Process steps. For example, you would have, let's say you would have something simple like a lipstick. Is a chemical product. Okay, so in the product design, in that first step that is already in blackened state there, in the first step, you would design, okay, you would say, okay, I want to have a lipstick that would have certain consistency. So when I put it on my lips, it will actually stay, and I can actually put it on my lips. It will not rub my lips, oh no, that kind of stuff. So the properties would have to be consistency. Then I would decide, okay, I want 4 different colors. So these are the definitions of what the product characteristics should be, which are done during product design. And then process design, how do I go about putting this together, is I would have some kind of gelatin or whatever they use for that. I would have some additives. And so the process steps would be to mix all of it together. Second process step would be extrude it into a big one long stick. Third step would be chop it all up. And the fourth step would be package it into tubes. Okay? So that will be the process design for that kind of stuff. What we do in here is we design the process steps in terms of more complicated processes, like you've been talking about in the sessions until now, when you were talking about technology. The process steps are usually a little bit more complicated. Does it make sense? Is everybody with me there? And I'm looking at you guys back there who are non-process engineers. Okay. So process design, we in this company, unless we are in the sulfur group, we don't do process design. We do usually, not always, because we can do it. We sell our expertise in that area. We can do process design. We have excellent process engineers who can do that. So if you're out there talking to some potential clients, you can tell them this is what we are excellent in doing. Normally we get this from some licensors. The third step is system design. And in system design, we mean we take those process steps, like for the lipstick, it will be mixing, extrusion, chopping up, and so on. So we would actually, in the system design, we would design the system. We would put together the configuration of a mixer, some loaders for all these ingredients, some kind of device that would push it out, and then push it through some kind of other device which would create the extruded long stick. Then the next thing would be, there will be a chopping device. See the difference between second and third step? Second was just process steps. Now we're talking about actual equipment in a configuration, in a system. Okay, now our company is really mightily engaged in system design. In fact, we have analyzed some time ago that our process department spends about 70% of the time doing system design, with the help of a bunch of people. And today we're going to be talking about system design. So I'm going to be asking everybody to pitch in and tell me what you are doing, helping to design the system and put it into certain configuration. Now, after the system is designed, comes detail design, when all other engineering groups really go full blast and design details of the chopping device, details of the mixing device, and so on. So this is really our mainstay in engineering groups. And finally, We put out all kinds of construction drawings, and what happens, the next step in bringing the product to the consumer happens, and that is construction. Anybody here from construction department? Anybody here from rigging department? Rigging design? Anybody from scheduling? Hey, good, okay. So you in scheduling will prepare these little sticks on the charts that tell us how long certain activities last, and construction will be included in there for jobs where we actually do construction management. Most of the time we don't do construction ourselves, we just manage the construction. Very seldom we hire direct labor and manage and actually do the construction ourselves. And the final stage in bringing the product to the consumer, for the lipstick thing, the construction has taken place according to the construction drawings that were prepared during what phase? Detailed design, that's right. And so operation takes place. Do we get involved ourselves? Anybody here is operating anything? I doubt it, because this West Coast operation is not involved in operating any plants, except I hear there's something going on near the airport, and we might have some involvement there in operation, but I haven't really spoken to anybody who would be involved in that. Somewhere there. Yeah.
Are you talking about the El Segundo refinery?
Not the refinery. There was some soap plant or something. Okay, so I put all those 6 steps here together, and you can see the order of them on this one little chart. Product design shows in small characters, meaning we don't really do that all that much. Process design, we do some, and we do get heavily involved. If we get something from the licensor, we really check them out. So we are involved in that. System design is mostly process department. Detail design, we do a lot, and that's where we make most of our money. And then construction management and operation. Finally, the lipstick comes out, and Senor Consumer and Senorita Consumer will use them. Okay, so you got consumers there. Now, one thing I wanted to stress out, any type of, this looks like a pyramid, and it really, in real life, the job that we do is like a pyramid. If we make a good base, if the product is designed properly, if the properties are defined properly, then the process design can take place. If the process design is done right, system design can take place. However, if those first 2 are not done right, it's like a pyramid. The top starts sinking. And we have to go through 2 things that we normally do in our work, 2 concepts that you will hear a lot about. One is iteration. We go over the same stuff again. It happens because of the normal course of work, but it sometimes happens, unfortunately, for the clients, if those bottom stages were not done right, we have to iterate, fix them up again, and then go back to what we should have been going and doing properly in the first place. We have to recycle, and that's called iteration. And the second concept that we use a lot in our work is soft boundaries. Now, these 6 layers that were shown there are defined in uncertain terms. However, many a time the boundaries between them are kind of soft. The work that would have been in one stage is actually pushed to the next stage, and vice versa. People, you and me, we go and nominally we are in the XYZ department, but there is a surplus of work in other department and a shortage of work in our department. We have to be prepared to go into some adjacent work, maybe we're familiar with it, maybe we're not. So we ask questions. So I think you should listen to all of these presentations carefully and make sure you understand what the other guys are doing and gals. Any questions at this point? Yes, sir.
The top boundaries, the last point.
Yeah.
I didn't quite catch what is the point of them?
There's a twofold principle here, that the boundaries between these different activities are not a hard line boundaries. Sometimes we do things that should have been in this phase, we do it in another phase. For example, system design might be taking place while detail design is already taking place, and vice versa. Now, some of it is due to the work procedures that we use, but some of it is due to the fact that the prior phase was not completely defined when we were told to go to the next phase. Make sense? Okay. And then people movement is also, I am in my XYZ department, and I think that I'm never going to do anything else. That's a fallacy. I have to be prepared to go and do other things. And from all the years of experience that I have, I can tell you it's fun. And then one of these days I talked to somebody like Joe, and he's wondering why I know something about rotating machinery. I'm not a specialist, but I understand what he's doing, maybe. Okay. The next one, we're going to go, so this completes the first handout. And we're going to be looking at the second small handout. This is just a broad brush repetition of what I already told you, but it'll be from a little bit different angle. No, I'm okay. I have to find, you can think of some questions while I'm fishing around. I think I found it. Does this look like your second handout? Yes. Okay. Because some of them look very similar. Okay, so today we are going to be talking about the third layer from the bottom, system engineering, most of the time. And the system engineering is part of what process department is involved in. I remember I said 70% of the process department work is in systems engineering. And the systems engineering is normally associated with preparing P&IDs. Now, in the past, in the old Parsons, systems engineering, doing systems design, was called mechanical process. If you were in the company 10 years ago, before this reorganization took place, you would be doing mechanical process. Maybe. This is for the process engineers. And so today it is a part of process engineering, and it could be one day if you go to another company, don't do that, but if you go to another company, you might be in systems engineering department. For example, Bechtel calls it like that. They don't have an office here. Okay? So don't get any ideas. So you will sometimes you'll hear about system engineering, sometimes you'll hear about mechanical process engineering, sometimes you'll hear about process engineering, or in some instances, in some small companies, they call it project engineering, but it's really doing P&ID work. Now okay, so defining the front end of the work. When we have this lipstick, for example, production, we decide we want to look at it, and in that first product design stage, somebody prepares what they call a feasibility outline or concept outline, that we're going to have some mixers, we're going to have some extruders, we're going to have some chopper, and so they prepare a sort of very early, rough estimate of what they need, call up some vendors, and in a week there is a feasibility outline as to what we're looking at, and then they go before a board. This, again, doesn't happen here, but you might as well know about it. They go before some kind of board, some kind of committee, and the committee says, yeah, that looks good, maybe that lipstick will sell, so we're going to go ahead and do a little bit more work. So a little bit of more work would be prepare a block diagram, like I started there, but I didn't have a good marker. So they say, okay, block diagram would be this step, this step, this step, without much care about equipment. And then they get a little bit more detail about the accessories that they need for their process, distribution network, and so on, and go before another committee. And this committee approves further design. So then they talk about design criteria, which is really product design. They say, okay, we're going to make these 4 colors, and so on. And they keep going, doing preliminary legwork, and finally they prepare basic process flow diagram, where these process steps will be clearly defined with pressures, temperatures, and flows. And if they find out, for example, that some of the chopping has never been tried before, they will cook up a batch in some kitchen, company kitchen maybe, and then try chopping it up and see if it bends or if it creates a lot of mess, and so finally they work out the process steps. Then they correlate the test data, fix the PFD. PFD is what? Process flow diagram, because we have that now. And then they test economics of the project. Again, they now have a much better idea, because they've been through it the 3rd time maybe, much better idea of the cost. Finalize what they call a front-end documents, which is a complete package of some block diagrams, some write-ups, some information on prices, and that goes before another board. And if the board approves going ahead, they have a process, and then the systems engineering starts here. Now, after this, and we're going to go through it a little bit more detail in the big handout, but this is where it might come to us, and we might start working on the actual system. So we'll develop a plot plan. Plot plan would be seeing how much space this equipment would occupy, how it's going to be connected, and so on. And we would start working on the piping and instrumentation diagrams. Now, sometimes you will hear about process and instrumentation diagrams. That really means the same thing. The standard way of calling these is piping and instrumentation diagrams, P&IDs. You'll hear other titles. I'm not going to spend too much time on this. If you want to ask any questions, you can do so now. But we're going to go through it in much more detail. Okay, any questions at this point? I just flipped through it. I'm really rushing. I don't want to spend too much of your valuable time going over it again. Okay, no questions? Should I start asking them? Okay.